uh, so you get some picture how to involve those energy systems into training, right?
Yes, sir.
Got
Like,
some idea?
yes, sir. That what are the immediate systems? What will be
Hmm.
used in the some prolonged activities, and what will be used for long term? I got a basic idea about that. So
Okay,
basically, talking about that phosphate system, then anaerobic lactic or glycolysis, aerobic glycolysis. I read about these.
that's great. And have you got some ideas how we incorporate those things into sports training and rehabilitation?
Yes, sir. How these components, how they are broke down, and what kind of activities we utilize these systems.
That's great. And what about you, Apurva? Studied something?
Good afternoon, sir.
Good afternoon.
Yes, I've studied whatever I was confused about in the last class. I read
Okay.
about the ATP mechanism, the ADP, usage of ADP, then
Mhm.
the whole new compound analysis of adenosine diphosphate, how it is made, and the
Mhm.
cycles. And basically, high energy phosphates, low energy phosphates, I have summed up a little bit.
That's great. So, shall we start the class now? Next.
Yes.
Sure, sir. Sure, sir.
So, what we were discussing last time, I think metabolic effect of exercises we have to discuss, right?
Yes.
Metabolic effect of exercises on body, right? So,
Yes.
till now we have covered. Today, this will be a discussion class. On each slide, we'll discuss the things, right?
Okay,
Okay.
sir.
Yes. Hello. Okay, are you seeing it now?
Yes, sir.
So, I think we have covered. We have covered till here. These things we have discussed, right?
Yes, sir. Last time we discussed this.
How many times, by what duration, what is the extent of what system, right?
Yes, sir.
Now we'll study what is the body response to these systems, right? What is the body response to any stimulus exercise? When we start exercises, body also produce some effects, right? It will be raised in temperature, oxygen intake will increase, and the it will be like somewhat unbalanced state of body because it will be predisposed to certain exercise, right? So, have you heard the term deficit, oxygen deficit, or steady state?
Yes, sir.
Uh, so, what do you understand by this oxygen deficit, if in your words?
So, oxygen deficit is basically the time when, when person is exercising and
Mhm.
they reach to a certain limit,
Okay,
and there is no further increase in oxygen uptake of the body.
okay. See, there are two terms. One is oxygen deficit, Other is oxygen debt. Have you
Depth.
heard oxygen debt also?
That I have heard it long time ago somewhere
Okay.
that
See, deficit means what? If you go by general terms, deficit means lack of something, right?
yes, sir.
So it's a term where we lack something, lack of oxygen, right? Oxygen deficit means
Hmm.
lack of oxygen, right? And
Hmm.
there is debt. Debt means we have to some kind of loan we are having, which we have to repay. Okay, debt is that. So what is this? Deficit and debt means when we start exercises. Initially, the anaerobic cycle will take over. At that time, there is no oxygen available for exercises, or also the muscular level, right? So
Yes.
that period from where onset of exercise, there is availability till the availability of oxygen, that anaerobic period of time, that is called as oxygen deficit. So that depends like on training. When we train someone, we see the time, like by what time the oxidative system take overs, right? So that if that time will be shorter, there'll be better. The athlete will go into oxidative system as soon as possible, right?
Yes, sir.
Clear?
Yes, sir.
And depth is what, when we do exercise for longer duration of time, right? Means if you do exercise for 50 minutes, 60 minutes, or 1 hour, or more than 1 hour, after that the body will be drained of oxygen, right? The every penny of oxygen will be utilized by the muscular muscles, right? Then we have to replenish those stores. We will consume more exercise instantly from the repay those systems, right? So that is oxygen debt at the end of exercise, and at the onset of exercise it will be oxygen deficit to the body. Okay, clear?
Yes, sir.
Clear. And what do you mean by steady state? See, steady state is what, when we use oxygen initially, when we start exercising. So initially we'll require more. Have you exercise? Have you sometime you run or jog? Have you done that? Or do you people exercise sometimes in a week or two, or not in routine?
Yes, we have exercised. So I have
Yeah,
exercised. Like,
you have exercise.
Yes,
Huh?
sir.
mm,
When you start exercising, you'll feel initial 5 minutes or 10 minutes, you will be feel more drained, right? But
mm,
after the body will attain some kind of temperature, and some sweating will start coming, and then at some time you will feel relaxed in between, right? Have you experienced that when you
Yes,
start
sir. Yes, sir.
yes,
exercise, you'll be like when you will do one lap, you'll think of stopping, okay? But once you do second or third lap, by the time you'll enjoy the exercise, and you'll be in a pleasant mood, pleasant state of mind, right? So
yes,
that state basically is oxygen, because when the oxidative system take overs, okay, it when it take overs, and it will provide continuously the oxygen to the muscles. The muscles will be in a relaxed manner. They'll be exercising in a smooth manner. So that state of muscular level or the body level, cardiovascular system, that state will be steady state. Okay, and the trained athletes, when we see when we run, will be attaining those steady state later. But what for trained athletes, they'll be easily reaching that state. Okay, so that will be the difference between a trained and an untrained athlete. So how it respond to the exercise stimuli, right? So that is the difference between a trained athlete and a layman subject, right? Clear?
yes, sir.
Yes, sir.
uh, then it comes oxygen deficit and debt. Debt, as we already talked, is following the exercise bout. O2 consumption is elevated for a period of time. See, it will not be when you stop exercise suddenly. Have you seen when you stop some bout of exercise, suddenly you will be gasping more air? Oh, and after some time, it will be slower, 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 slowly, it will be the normal breath, right? So that instant amount of requirement of oxygen, that will be called as oxygen debt. How much you have utilized during that state, during that running, during that exercise, so that will be body requiring it back. Okay, that will called as oxygen debt, right? Steady state we have discussed. And see, nowadays oxygen debt, that is also called as excess post exercise oxygen consumption, right? Because post exercise will be consuming more of oxygen, so that is a proper term for oxygen debt, right? Clear till now?
Yes,
Yes.
sir.
See, you can ask in between if you have anything regarding these terms and all. You can ask in between, right?
Okay.
Okay, see, when we talk about deficit and EPOC, so why these terms are there? See, initially, as we discussed, there will be synthesis of phosphocreatine, and then the blood will restore the oxygens, and quickly the phosphocreatine will be utilized, and it will be replenished. Okay, after that, what in previous slide, have you seen the oxygen depth, right? The depth the body will take back, it will be in two manners. One will be rapid and one will be slow. Initially there will be synthesis of phosphocreatine, which we have used during the exercise. Okay, and there will be synthesis of the stores of muscle with the oxygen glycogen level. So there will be requirement of very fast, very fast oxygens, right? But after some time, the O2 depth, the oxygen will be required slowly, and over a period of time, like 4 hours, 5 hours, 6 hours, the body will consume oxygen, and it will be replenish all the stores, right? So first, why the long term is required and why the short term is required? Short term is required to reach the again the steady state of the body, right? But the long term will be required to wash out the lactate, to keep the temperature of the body elevated for prolonged period of time, and the heart rate and the breathing to normalize those patterns. So this will be a long term effect of oxygen depth. Okay.
Okay, sir.
How the lactate will be removed? Uh, have you you know na lactate? What is lactate? Lactate is obviously the end product of exercises. What will be accumulated in the muscles, right? And it
Yes.
will cause soreness of muscles or this DOMS and all those things. This will be due to lactate only, right?
Hmm.
So how it accumulates, and how we remove those that lactate, right? That will be depending on the type of exercise we are doing, right? If we are doing short term intense exercise, right, very high intensity but short duration, so what will happen? 0 to 10 second the ATP PCR system will be only utilizing the thing. So the but glycolysis, what happens after 20 seconds, right? When glycolysis happens, then only the anaerobic product like that lactate will be produced. So if the burst of exercise will be just for 5-10 minutes, 5-10 seconds, so it will not be accumulating any lactate, right? But when intense exercise and it exceeds 20 seconds, so ATP production will be by glycolysis, and that will further add on the lactate to the system, right? Then after longer duration exercises for 60 seconds or more, like some sports like hockey, football, there'll be like more than 60 seconds a player will be exercising on the same intensity. So that time ATP production will be primary by oxidative mechanism, right? So what happens when the oxygen more than 60 seconds, if we are exercising, so that type of high intensity exercise, there will not be production of lactic that much. And if it will be produced that will be washed out continuously during the oxidative cycle. But during intensity, like 100-meter sprinter, 200-meter sprinter, or 400 also, so that period will be 20 seconds to less than half minutes, right? So that time there will be more of accumulation of lactic acid. So that has to be washed in a periodic manner by doing the some slow of intensity recovery exercises, then by icing and all those things, so that will be replenished. Okay. When it comes to prolonged exercises, but it will be more than 10 minutes. So what we have discussed earlier, like more than 10 minutes, if will be working, so that will be taken over by the oxidative system, right? Then steady states will be achieved during that period. So that period, if steady state is achieved, so that means we have to maintain the oxygen level to the muscles, and that will be done by your breathing, and that will be circulating to the system. So that time there will be washout of the lactate will be very slow in progress. So if will not right if will not be consuming proper, our lung capacity will not be proper, our respiration and all will not be proper, the environment will be like, if environment is very cold and humid, so it will be like will be drained very easily. So that time the accumulation of lactic acid will be more, and the drift of oxygen uptake will increase, right? So that happens, and if oxygen will intake will increase, then that means that will be more dependent on the oxidative cycle, right? Clear?
Yes, sir.
Then the incremental exercises. Incremental means initially it will be low intensity, and slowly the intensity of exercise will increase. So the workload will also increase slowly, right? And the VO2 requirement will also increase slowly. So that will be adding that our cardiorespiratory system has to deliver more exercise, more oxygen to the muscles, continuous, right? Clear?
Yes, sir.
See, when we talk about incremental exercises are uh, slow intensity or fast intensity, but it will be progress slowly, right? So first, what will happen? Have you heard the term lactic threshold? Threshold, have you heard?
Threshold, yes, sir. That is
So
the minimum amount required to achieve anything.
yeah, minimum required. So that is in lactate also, we have a lactate threshold, like minimum amount of lactic acid that will be accumulated per minute of exercise or per second of exercises, right? So that is a formula from where we calculate that how much lactate acid has to be accumulated, and how much if it will be above certain level, so that will cause muscle soreness and all those things. So it will be causing a problem in recovery, right? So what happens when we do incremental exercises? So lactate threshold, when we do intense exercise and rapid for shorter duration, so that threshold is reached easily. But when we do incremental exercise, it will be delaying the threshold, right? So that's what we sometimes we do now. We start with slow jogging or warm up kind of exercises. Then we move on to higher intensity exercises because of to delay or to prevent the lactic threshold level, right? Okay.
Okay, sir.
So what will happen when we say if there are oxygen level is low in a muscle, right? The individual is doing higher intensity exercise, the low muscle already having less oxygen. So what will happen? So there'll be like there will be more fatigue to the muscles early, right? fatigue will be happen, and the accumulation of lactic acid will be more. And when if we have proper ventilation, proper you can say lung capacities, proper training, and then the threshold will be delayed, right? Clear? And then comes to glycolysis. See, when anaerobic glycolysis system take over, we have heard that, we have studied that previously. Can you tell by what second or what time anaerobic glycolysis take over?
So anaerobic glycolysis is generally between 30 seconds to 3 minutes.
Yeah, 30 seconds to, actually it is 30 seconds to not 3 minutes. It is up to 2 minutes, or yeah, 60 to 120 seconds. Okay. So after 3 to 4 minutes, it will be oxidative cycles,
Hmm.
totally on oxygen, right? So what happens in? Have you heard of Krebs cycle?
Yes.
Studied Krebs cycle?
Yes, sir.
What is Krebs cycle? See, Krebs cycle is basically the oxidative cycle, right? In which there will be breakdown of the pyrite to acetic acid in plus oxygen. Then the Krebs cycle take over to oxygen to H2O. Okay, so that is the cycle is again we form oxygen and water in that is called as Krebs cycle, right? Clear?
Yes.
So basically, in incremental exercises, the initial the phase will be of anaerobic glycolysis system. Then the when aerobic will take over, so it will be requiring more of oxygen or carbohydrates from the muscle. It will be more of from free fatty acid. Have you do you know free fatty acid? What fats and fatty acids are available in the bloodstream, right? That will be utilized more as compared to the muscle glucose or muscle glycogen. Clear? So primary source of when we do the exercise, start the exercise, primary source will be muscle glycogen or muscle glucose. Then it will shift to blood glucose level on the when we increase the duration or intensity of exercises, right? See, now we'll talk about exercise fuel. What fuel and by what time what fuel is utilized? It is called as exercise fuel, right? Do you know exercise? Basically, any exercise basic energy providing will be ATP, glucose, or your fats, protein, triglycerides. These things will be the energy sources, right?
Yes, sir.
Clear?
Yes, sir.
The primary source of exercise. See, there is a concept in which you can say that concept is crossover concept, like metabolism of exercise. What metabolism in the body is happening due to the onset of exercise, and what intensity of exercise it is. So that will be depending totally the utilization of the fuels will depend on those two things: how body metabolize the energy source, and what is the intensity of exercise, right? See, for shorter duration or during the early stage of prolonged exercise, carbohydrate will be primary fuel. First fuel will be carbohydrates, and that carbohydrate which is stored in the muscles. So that will be basic primary source, right? Then for if the duration will go on longer, then fat will come as predominant source, right? Then when the fuel requirement will shift from carbohydrate to fat will be in longer duration, and when will it will happen? It will happen in blood glucose or blood muscle glycogen stores are there, so the carbohydrate will be taken from that area, and fats will be taken from plasma or free fatty acid or intramuscular triglycerides. This will be that will be the primary source of fats, right? And protein will come from the muscle protein which is there, and it will add on only 2% of energies. And the blood lactate itself is, lactate is sometimes you can say byproduct of exercise, but sometimes it gives you instant energy also. It is a energy, as an energy source also we can use the lactate, because when the lactate will accumulate, so it will be again in the presence of carbon dioxide and all, the LDH will convert into the ATP, and the hydrogen ion will be separated, so that time it will also add up some kind of exercise, some kind of fuel, right? So now it comes to energy source in a highly trained endurance athletes. So if endurance athlete, what we have talked, endurance athlete will be who will be doing the exercise for longer duration of time, or you can say for more than 1 hour, right? Then in that case, fuel sources will be primary from FFA, that is flowing free fatty acids. Free fatty acids from the that bloodstream. Okay, and when it comes to middle intensity, it will be free fatty acid from the plasma and muscle glycogen. But when it comes to high intensity, then muscle glycogen will be the predominant source of fuel, right? And contribution of four energy sources or prolonged in endurance athlete. So what will happen if we are doing exercise which requires 70% or more VO2 max, or it will be less than 1 hour. So glycogen will be the primary. When 70% of VO2 max, only glycogen will be the primary source. What glycogen is stored in the muscle, and if you go beyond this or beyond 1 hour, then free fatty acids will be the primary source. And free fatty acid and triglyceride, they combine 50% of fuel, right?
Okay, sir.
Clear?
Yes, sir.
Yes, sir.
So these are the points. Now we can. I think if we'll discuss the things, then we can get more clear picture, right? So you can ask any questions if you have regarding this.
Sir, I have a question.
Okay.
Sir, as you told, at the steady rate, when the VO2 max is maximum, after the sport is over, will that VO2 max decline to some extent, or it will be a gradual decline?
See, that's what I told. There will be two type of method of paying the oxygen debt, right? There will
Yes,
be
sir.
one method will be slow method, other will be faster, right? In the
Yes, sir.
faster method, the VO2 max will be more. The we will be requiring more oxygen instantly, right? And at that time,
Yes.
the because the ATP, PCR, glycogen stores, everything has to be replenished at a faster rate, right? So at that
Yes.
time, in initial 1 or 2 minutes, it will be more VO2 max, right? That is required to the body. But
Yes, sir.
after 2 or 3 minutes, there will be slow requirement to cope up those temperature level, to cope up that stores, or and to basically to wash out that lactate accumulated during the exercises.
Yes,
Okay,
sir.
so that will be at that time VO2 will be required, but that at a slow and steady pace, not that instantly, right?
Yes, sir.
Okay, next. See, here we have studied that thing, right? Initially, what we have seen, the synthesis of resynthesis of PCR or restore of blood glucose and blood level. So the O2 will be fast, O2 depth, right? That will be required very fastly, right? But in later state, it will be to that relieve the lactate level and all, maintain HR and the breathing level. So it will be slow in pace, right? Clear?
Yes, sir. So basically, sir, when we train the athletes or sports person, we
Mhm.
usually tend to maintain their VO2 max level.
Yeah. See, VO2 max is not what we have to maintain. VO2
Yes, sir.
max is what we have to just be. VO2 max is a, you can say, indicator, right? It's
Okay,
a
sir.
indicator of like how much the person is requiring oxygen at what level, right? When see
Yes, sir.
what why we measure VO2. VO2 max. VO2 max is measured only as an indicator, like how fast athlete is getting deprived of oxygen, how much oxygen is required at what stage of exercise. Like if we'll take a VO2 max during first 5 minutes of exercise, then 10 minutes of exercise, then 20 minutes of exercise. So this will give you idea, like first 10 minutes it utilized this much of oxygen, first next 10 minutes this much. Then if we do some training, like in initial 5 minutes, if we'll increase the intensity, right? 5 minutes
Mhm.
high intensity exercise, then low intensity, then high. If we'll that keep on changing the intensity, so that oxygen requirement will also change, right?
Yes,
So
sir.
that way we train and we monitor those VO2 max parameters, right?
Yes, sir. Okay, sir.
Okay, tell me next.
So basically, sir, in what we have studied for the patient population is that lactic acidosis happens when VO2 max reaches.
Mhm.
So that is the point where we should stop the exercise.
See, it's not matter of stopping the exercise. See, when VO2 max reaches about 90, 100%, right? So at that time, what we'll do, see, obviously, when the oxygen level, when the body, that environment will not be able to provide proper oxygen and the oxidative cycle is not happening. So when the oxygen depth will be there, so obviously there will be accumulation of lactic acid. But
Yes.
lactic acid has to reach to certain level to stop the exercise. It's not like intensity. That's what we have talked about, lactic acid threshold, right?
Hmm.
At what time we are hitting the threshold, what time we are hitting the peak, and what time, by what time we can maintain that plateau of lactic acid, right? Lactic acid also, it doesn't mean that 1% of lactic acid is there in the system and we have to stop exercise. We have to train lactic acid cycle also, right?
Yes.
So like you can say lactic tolerance. Have you studied the term lactic tolerance, right? Some athletes, there is inbuilt lactate tolerance, like some athletes will be tolerating lactate at a 1 millimole, or some will not be tolerating it to 0.5, point 0.2. So it happens to it's sometimes naturally, sometimes we train that thing to to bear that lactic acid, right?
Fine, sir.
And especially for us as a physios, what happens, some athlete comes like kind of DOMS you have studied, right? When we do some intensity of intense exercise sometimes in between, so the player we come after soreness and all those things. And what we'll do, we if we'll do intense massage to remove that, and all, so it will add on further it will add on the soreness. So we have to be very precise in prescribing the rehab exercises also. Like if athlete is already in a state where lactic acid is accumulated and the muscle soreness is persistent, if we'll do some exercise or some manipulations, so it will add on the soreness of the muscles. So we have to think of adding a nutritionist also in this cycle to add some drinks, to add some recovery fruits, drinks, so that it will be washed very fastly. So nowadays, what we do as a rehab personnel in the team, we don't deal any injuries or any problem individually. We take everybody in loop, right? If an athlete comes for me to any problem of any these cramps or strain or sprain, so what I'll do my rehab exercise, I'll give it a chance, and I'll refer to the nutritionist also. So what she'll do, she'll add on, like sometimes there's a minor injury or trauma or micro tear at the muscular level. So what we have to do? We have to add some protein level also, right? For recovery, we have to add some fluids for water and hormonal that you can say imbalances. So nutritionist will help. And sometimes injury perception in mind, some athlete is what happened, it is having a minor injury but he'll perceive it more. Sometimes it is a major injury and the athlete will keep on working, he'll not take that very seriously. So at that time we need a psychologist also, right? So
Okay.
what we do, we keep every person in loop, and a medical doctor also required for medication and all. So now, as a rehab personnel, we have to work as a team. So that's what happened. That's what I'm telling. If a person is having any sort of injury, and the rehab exercises are as important is his diet, as important his psychological counseling, as important it is the medical management of that problem, right? Clear?
Yes, sir.
So,
Okay, ask. Yes. Okay, tell me. Okay, any other questions?
No, sir, not from my side. Apurva, if you have any.
no, ma'am, no, sir, no questions from my side too.
Okay, any further, if you want anything to add on to this topic of exercise systems and energy utilization, or anything, any point you want to add on, like what we have to discuss. If I have missed some point, is it something to discuss?
No, sir.
No, sir, no, sir.
Okay, basically, now what our requirement about this topic was this. We have discussed aerobic and anaerobic systems,
Yes,
right?
sir. Yes, sir.
We have reviewed the energy systems.
Yes, sir.
Yes, sir.
Then we have seen the metabolic response to exercises,
Hmm.
right?
Yes, sir.
And what activities use what energy systems. We are clear about this.
Yes.
Yes, sir.
And now we have assessed the sport specific energy demands also, right?
Yes, sir.
See how we have assessed that thing, that if we'll do endurance workout, what energy systems and what kind of energy demands will be there. That is
Hmm.
all depends on the energy fuel sources and what will be the kind of sports we are playing, right?
Right.
And how to train specifically. If we have to train a sprinter, we have to train him specifically. If we have to train a middle distance runner, that will be different. If we have to train a marathon runner, that will be different. If we have to train a hockey player, football player, that has to be different. And that has to be different in a way of energy system requirements, right?
Hmm. Yes,
We
sir.
we clear about these points.
Yes, sir.
Yes, sir.
Anything else you want to add or you want to ask?
So we need to follow which book to read about this? Just the
Okay.
exercise physiology book or any other
I
thing?
think exercise physiology book will be good. That what
Catch and
name?
catch.
Catch and Catch is good, and
Will
Wilmore is also
Will
good.
more is there? Yes.
Okay, and one more book is there. I have one book comes with athletic management of physiological demands. Okay,
Okay.
I don't know his writer. Okay, search it in Google or something, right?
Okay, sir.
And basically, Catch and Catch is very good book. Everything you'll get in that, right?
Yes.
But main thing is that in Catch and Catch, na, it's very elaborative thing.
Elaborative. Right.
When we have to do research, then 1 point from there, 1 point from there. But Wilmore sometimes, na, Wilmore it's very specific. Wilmore is good for that. Okay.
Yes, sir. So will
So
you be able to take a class tomorrow at the same time?
tomorrow,
Tomorrow.
uh, tomorrow is what? If we can take it on Wednesday, is it possible?
So Wednesday we have another class. Then we'll have it next week only.
Okay, next week only. So tomorrow, actually, I can confirm by evening because tomorrow is
Okay,
a
sir. No problem. You can confirm by tomorrow morning as well. No problem.
no problem. Then if I'll be free from tomorrow evening, I'll give you a message on that WhatsApp, right?
Okay, sir.
Then we
Okay.
can have class.
Fine,
Okay,
sir. Fine,
okay,
sir.
done. Then
Fine,
we
sir.
can wind up the class, right?
Okay, sir.
Thank you, sir.
Thank you,
Okay,
sir.
welcome.